Today we're going to take a tour through the world of tools for doing web-based visualizations. So a web-based visualization is a visualization that can be run in a web browser. It's not an image that we embed in the page, it's actually drawn as part of the web page itself. You can do this with old school HTML if you want. More commonly it's done using CSS, cascading style sheets, JavaScript for some code that can automatically process data files, and HTML5, which is the newest version of HTML that supports some kind of interactivity in drawing. So D3 is a JavaScript library for doing data-driven documents. And the idea is that you're making native web pages that show visualizations themselves. To do that, let's just start and take a look at the D3 website. So they have all kinds of examples embedded in here. Let's just take a look at a couple of them. So what we're looking at here is unemployment rate by county in the US from the Bureau of Labor Statistics. And you can see we have each county colored by its unemployment rate. This is not an image in the web page that was made in another application and is just embedded. This is actually drawn in the web page itself. And if we scroll down, you can see that they're showing us some of the data that they used and a little bit of the code that's helping to draw this on the page. If we go back, there are also some interactive options. For example, this one shows us a bunch of circles packed inside other circles, and it's zoomable. So if you click, it will zoom in on one, and then you can progressively zoom farther. If you click on the latest level on the inside, it will zoom you back out. So again, this is not an embedded application. This is done all directly in the browser using JavaScript, HTML, style sheets, and then the D3 library, which is a JavaScript library. We're going to talk about doing web applications. We're going to look at a few of the components, but it does get sort of programming heavy to go make a D3 chart yourself. Normally I would walk you through a tutorial like this and try to get you the gist of it, but there's about 15 different things that I would just have to tell you, trust me. And so I'm not going to walk you through it. I have included a link to a tutorial to walk you through making your own data-driven chart with D3 that you are welcome but not required to complete. So if you want to play around with JavaScript and learn some new commands, that is a great thing to do. If that's a little overwhelming for you, I'm going to show you some other options. But I do want to get us a little bit into what the code looks like to do this kind of drawing without getting all the way into the complexities of D3. So a web application is going to have HTML that gives you the structure of the page, CSS, cascading style sheets, that gives you the visual appearance, colors, borders, that kind of thing, and then JavaScript, which gives you the code that allows it to actually behave and respond. So stuff we're going to need. First, HTML. This is the hypertext markup language. Hopefully most of you have encountered a little bit of code in HTML if you're not proficient in it. And it's essentially used to create any page that's on the web. It is supposed to just have the structure and the content, though sometimes it also has the visual elements. So I thought we would walk through an example of building an HTML page that will also have a few graphics on it by the end. You can follow along with me. I will also upload the code for the HTML page that we're going to develop so you can take a look at what I've typed. So I'm going to switch over to my plain text editor here. HTML documents all have tags. That's in the less than and greater sign. I'm just going to call them brackets. We always start with the HTML tag, and then the document ends with the end HTML tag. So it's the same tag, it has a /, and that means I'm closing off the one that I started at the top. There's then two parts to an HTML document: the header section, which we'll create with a head and end head tag, and then the body section. The header section contains content that doesn't show up in the main web page window. Any metadata about the page, like the author, keywords, any other data like that, goes in the header, along with some style sheets code if you want, some JavaScript code. The tag that we most often see there is the title tag, though. And so we have the title tag and then some text and then the end title tag. This is what shows up in the very top of the browser. So we're going to take a look at that as it is. I'm going to save this. And then to look at a web page that you have created, you can just go to File and Open File. So you're not going to open it off a web server, you're just going to open it off your computer. Ours is called Simple HTML. And if we open that, there's nothing on the page but the title you can see up here in the top bar. Everything that goes in the body section of the document is what's going to show up in the main window here. So we could just put some text in that says, Hello World. Save that, flip back to the browser, refresh, and there's our text. So that's a really simple HTML page with the basic components in it. And what you're going to do to build any web page is essentially use more tags. Learning HTML is basically just learning those tags and getting used to them, memorizing them, practicing them. If you're interested in that, drop me an email. I teach a 1-credit HTML and style sheets class that you can take. It's all online, and so it's a way that if you want to be able to make web pages and style sheets from scratch, or at least be able to edit them effectively, even if they're made by a tool, it's a way that you can learn. I'm not going to give you all of that material now. But so we start with HTML, and then this is an example page, looks a lot like what we just made. Cascading style sheets were introduced many years after HTML was created to separate the form, that's the visual appearance, from the content. So it used to be that you would always do visual elements with HTML. So if you wanted bold text, if you wanted to change the color, if you wanted to change the background of your page, that was all done in HTML. And you still can do it that way, but it's considered good practice to separate those visual elements out and do those with style sheets, and then have the HTML just contain the actual text and images, the content that's going to be on the page, and the structure of the document. So I'm going to show you a couple ways that this can be done. Style sheets are their own topic and complicated enough that I can't go into all of them, but I'm going to show you a few examples. So before, if we wanted to, say, change the way Hello World looked, we could use the bold tag, which is just B. So you put B here, that starts bolding. Everything that comes after it will be bolded until the end B tag. And if we were to refresh that, here's our text as it looked. And if we reload, now it's bold. Okay, so that's visual appearance. You could also change color, underlining, all of that using different tags in HTML. This is now considered not the best way to do it. I confess I learned to do it this way, and so I still do a lot of it just with HTML. But you can also do it all with style sheets. So to do that, we'd get rid of the bold tag, and we could say we're going to use the span tag. The span tag doesn't do anything by itself. It just says here is a span of text. If we were to save that and reload it, our text just goes back to normal. Span doesn't do anything. But we can put style information inside the span tag. So we can say style equals, and then in quotes, we can put whatever information we want to control the style. The stuff that goes inside the quotes is going to be cascading style sheets code, which is not really a programming language, but it's a syntax for representing visual things. So for example, we could say color, red. Style sheets are essentially just a bunch of name value pairs. The names are defined as part of the language, and they control different aspects of the appearance. So there's color, there's background image, there's text weight, text decoration, which allows you to underline and that kind of thing. Learning style sheets is a lot of learning what those attributes are. So we start with the attribute is the name, and then we have a colon, and then we have the value. There's a bunch of ways to represent color, but you can just use keywords like this. So now in our span tag, we have this attribute that says the style is any style sheet stuff that comes inside the quotes, and our style sheet is color, red. If we save that and reload, now our text is red. And you could put a bunch of attributes in here. So we could say the color is red, and then still inside the double quotes, text decoration, underline. Again, this is style sheets code. It's just a thing that you memorize once you're learning style sheets. So that will underline our text. So we have two styles contained inside the quotes, separated with a semicolon. And now if we refresh, you see an underline appears there. So style sheets allow you to control all sorts of things about appearance, colors and underlines, but also border, the sizes of things, the height and width, their position on the page, the fill color, the background color, all sorts of things. Again, if you want to learn about this, I teach that 1 credit class that you can take, and you'll get the full picture of all the complicated things you can do with style sheets, which is pretty cool. Next, there's JavaScript if we want to make web-based applications, including web-based visualizations. An important thing, please be smart. Don't call JavaScript Java. They are 2 entirely different languages. People sometimes, I think, maybe want to shorten JavaScript and just call it Java for short, but that's wrong. Java is a completely different language. It's been around since 1996, so the web was invented, basically launched in 1991. So it was around for a while before we got JavaScript. And it used to be super buggy. It's much better now. It has a standard. It's evolved a lot. It has many more features than it originally did. And it's extremely popular because it runs in every browser. So any browser you have is able to execute JavaScript that's embedded in a web page. It has its little bugs. Sometimes it doesn't work consistently across browsers. This was particularly a problem with Internet Explorer, which ran Microsoft's own version of JavaScript. Things have gotten better since then. And JavaScript is now extremely popular for creating all kinds of interactive web-based applications. I said it runs in every browser, and it's important to know that that's basically the only place it runs. You can't run a standalone program with JavaScript like an app that you would download on your phone or your computer. It only runs in a host environment. Primarily, that's in a web browser. We also have had the introduction of scalable vector graphics, or SVG. These are not just a web-based phenomenon. There's an SVG file format that's out there. These are documents that basically you can zoom in on infinitely, or graphics that you can zoom in on infinitely. There's also support for creating them now in web pages. There's a tag, SVG, and it allows you to create different shapes, circles, rectangles, lines, text, and you can also group shapes together and adjust those groups. So we're going to do a quick exercise. You're going to start and you're going to create your own simple vector graphics. I'm actually going to do it for you here, and I'd like you to try it out yourself. So download the simple HTML file that is linked up on Elms, and we're just going to add a circle, a rectangle, and some text. As reference here, to add a rectangle, you use the tag rect, circle for a circle, text for text, and there's attributes that you want to put in there. Common things to add as attributes are things like stroke, which controls the border of the shape, and fill, which is what color it's filled with. You can use cascading style sheets with these if you know them. So I'm going to show you an example, kind of a really simple way to get started with this, and then you're welcome to play around. But I do want you to try it and at least get this working yourself. So we're going to flip back over to our document. I'll get rid of the text that I had in there. And now we want to create these graphics. So for that, we're going to use the SVG tag. And then I always put in the end tag so I don't forget it. This is basically going to give us a canvas that we can draw pictures on. And so we want to add in a width, let's say 500 pixels, and a height of 500 pixels. Just one note in case you're not familiar with HTML, we've added these attributes to the start tag. You never put those in the end tag. The end tag never has attributes. It just closes off with the name of the tag. In between the SVG and the end SVG tag, we're then going to put the code for our shapes. So let's start with just a rectangle. We use rect as our tag. And we at least have to say the size of this. So we're going to give it a width, let's say 100 pixels, and a height of 50 pixels. And then we want to do a stroke and a fill. So a stroke will give us the border, and the fill will tell us what color to fill it with. So let's say stroke is red and fill is blue. Now, this is just going to draw a rectangle. It's not like other tags where we kind of start them and then we have some text and we close them. So you could kind of put the end rect tag here, but it's a little weird because nothing will ever go in the middle. So a shorthand for that is just to put the slash at the end. And that basically says we're starting and ending the tag all in one chunk. If we save that and flip back to our browser and reload, our hello world text is going to go away. And there's our rectangle. So we've got one thing done. You can try changing the colors. So you can use lots of color names. If you know how to do hexadecimal color, you can put that in here. So we could, for example, try to make this like a dark purple, which would be something like that. And we get this darkish kind of eggplant color. Okay, now that's starting up in the upper left. If we wanted that to move further into our canvas space, we could do that. And for that, we're going to give an X and a Y position. So that's the coordinates of the upper left-hand corner, and it's measuring how far are they from the upper left-hand corner of our canvas. So I'm going to put these up here. We could say X equals 100 and Y equals 100, which means start this 100 pixels in and 100 pixels down from the upper left-hand corner. If we save that and reload, you're going to see the rectangle shift down to the right. Okay, so now we've taken care of our rectangle. Let's add in a circle. So for that, we use the circle tag. Basically, we're going to use the same attributes. We can do an X and a Y, and instead of having a width and a height, we're going to do a radius. The radius just uses the R tag, and so let's say our radius will be 100, and we want to start where, we want to indicate where that's going to start. So if we did it the same as our rectangle, we would just copy and paste down our values here. But it turns out those don't work for a circle. When we flip back, our circle is still weirdly jammed up there in the corner. To set the XY position for a circle, we use CX and CY. If we do that, the circle is going to start in the same place as our rectangle, which maybe we don't want. But let's take a look at it just to see. Okay, so there's our circle moved down 100 and in 100, and it's overlapping our rectangle. You can just see it popping out there. If we want to move it in a little bit more, let's say 200 and 200. And now it's moved down. The reason that we use those different coordinates is because they're measuring the position of the center of the circle. Because we don't really have like an upper left corner. I guess you could imagine there's a box around it. But with circles, we determine the position by where the center is. And so since that's different than the upper left-hand corner, that's why we have to use CX and CY. That's the X position and the Y position of the center, which is what the C is for. We have not specified any stroke or fill, and so we've just got a big black circle, which is fine. Let's try doing stroke equals green and fill equals none, which means we'll have an open circle. And so there we can see we've got our green edge, and the circle itself is not filled. You can see through it and see the rectangle behind it. Notice that the circle's on top of the rectangle. That's because these are drawn in order. If we were to move it so the rectangle came after the circle, now the rectangle's on top of it and you can't see the border there. So it just draws them in order, and if there's overlap, whatever the last one to be drawn is will be on top. Finally, we want to add some text. So we're going to use the text attribute for that. Now we can just put some text and then use the end text tag. So the text itself actually goes between the tags, a little bit different than what we had with the circle and the rectangle. And if we just show that as it is, we can't quite see it. So let's put in an X position and a Y position so we can make sure it's on the screen. We'll say X equals 50 and y equals 50. And there, now our text is appearing fine. We can also add in cascading style sheets attributes here. So just like we did with the span tag, if you want to add in cascading style sheets in a document, you always use the style attribute. So we could use text decoration, which we saw before, and do underline. And if we save that and refresh our page, now we get an underline on there. So that's just a quick example for you of how you can put elements inside this SVG tag and actually draw graphics on the screen. What D3 does is leverage this ability along with some JavaScript to automatically process things and creates graphics that can be interacted with, that appear nicely on the screen, and that allow for zooming because they're SVG, which means you can zoom to whatever depth you want in them. So, data-driven documents, D3, is a JavaScript library. It's not directly tied to SVG. It can use that, or it can use the document object model, the DOM, which refers to different elements within an HTML document and allows JavaScript to control how they appear. It's up to you which one you use, and if you get way into D3, you'll figure out which ones are appropriate where. You can load up data files and then generate HTML code to show that in whatever form you want. So we looked at a couple examples, but that's basically HTML that has loaded data into showing it as bars or as circles or as a map, however you want to do it. So as an example, you can create a D3 bar chart. To do that, you're going to open up your data. You're going to use selectors, which are part of D3, to create events, like what kind of things on the page should be selected and changed. And you're going to use something called a join operation to connect data to the document object model. Objects, those are the things on the page. You could do this just with div tags, which are essentially rectangle sections of your document, or you can do it with SVG. If you make one, it looks sort of like this. So nice HTML, pretty looking graphics, natively part of the page. So it's not images, they load much faster, and they can be changed depending on how your data changes. As I said, it gets pretty code heavy to write your own D3 code, even if you're doing very basic examples. So like I said, I'm not going to walk you through an example, but I have included a tutorial for the basics. It is pretty straightforward to follow if you're comfortable with JavaScript and you're willing to kind of go along and trust what some operations are without getting super deep into learning everything about D3. So that's available for you if you want to try it. What we're going to look at is Vega and Vega Lite. So D3, really powerful. It lets you create all kinds of crazy, wonderful stuff, but it requires programming and a lot of learning of the library. It's not always easy, which you'll have seen if you looked at that tutorial. So the question is, can we kind of lift that abstraction and just put the data in and have something that's already going to be able to process that data and show it in different ways? To do that, there is such a tool. It is Project Vega. It's called a visualization grammar, and it basically gives you language for creating, sharing, and saving visualizations. You give it data in JSON format, and it will render it for you in SVG or on an HTML canvas object. We're going to go take a look at the website and try it out. All right, so this is the website. This link for you is on Canvas, and you want to click Try Online. This is going to open the Vega editor, and you want to make sure up here that Vega Lite is selected and not just Vega. So right now it says invalid spec, it can't work with any data. And so what we're going to do is give it some data to work with. I have provided you with a file called Seattle. Here I've flipped over to see it in my text editor. So this is a JSON file, and let me just walk you through it. So it has a few different elements. We have data, and we're then giving some information. The data is at a URL, and we're actually using an example data file in CSV format that Vega provides for us. But you could put in a URL of any CSV and have this work, and we'll take a look at that. We talk about then the mark. What kind of mark do we want to show up in the visualization? We have picked tick You can look at the different examples that Vega provides. And then for the encoding, we want to say, what is the x-axis going to look like? So the field from our CSV file, this is basically the column heading that we're going to use, is one called precipitation. And the type of data is quantitative. I actually have that data file loaded up in Excel here. And what you can see, let me zoom in a little bit for you, is that we have columns for precipitation, temp max, temp min, wind. These are all quantitative, and then we've got a weather column that has text and nominative or categorical value. So this is just so you can take a peek at what that data is that'll be loaded up. If we take this JSON, which describes the data, the mark, and the encoding, we can copy that, bring it over into Vega Lite, and paste it into the JSON window here. And it generates for us this really nice little tick mark graph where we've got the precipitation and it's showing us a line, and if we mouse over it, it tells us what the values are. We could change that. So if you remember, we had a field called temp max, and if we change that, it automatically updates our chart. We can do temp min, and it'll update with that value. Now, let's make some other changes. So for mark, we have tick in there. There's a bunch of different options. One other one you could do is point, and that's going to give us little dots. We can also turn this from just a line with a bunch of points on it into a scatter plot. So we can add in a y-axis. And then for the y-axis, we'll add in basically the same attributes. So we're going to do the field, and for this one, we'll use precipitation. And we'll do type colon quantitative. I need to put a comma between my x and y. And there we can see it automatically populates all of our data in here. So it's a quick and easy way, once you learn the few sets of attributes and can figure out how to put them in JSON format, that you can generate charts automatically. So if you looked at the code for doing this in D3, there's an awful lot of JavaScript that you would have to write. Here, you don't have to write that. You just define what data to load and then how to draw it, and it's going to automatically make this interactive graph for you. So a practical exercise for you. I basically want you to try what I just did. Down here you can see a little example of the first JSON that I gave you. I want you to open the Vega Lite editor, put in that Seattle data. You can just copy and paste that JSON in and explore it using Vega. And go ahead and try adding in other attributes. Check out the Vega documentation, which is linked in Elms, and see if you can tweak some of the attributes, like changing the ticks to point, adding in a y-axis, changing the colors. There's all sorts of control that you have over the visualizations. So to sum up, web-based visualizations are not just pictures shown in web pages, but it's visualizations created natively within a web page. So it's using HTML, style sheets, JavaScript, SVG, and everything is drawn and potentially interactive within the web. This makes it load really fast. It allows you to change it without having to create new graphics because you can just update your data file. And there's various ways to do it. So we looked at some basics of HTML for drawing the shapes. That's certainly leveraged by D3, and if you're comfortable with JavaScript, you can make your own beautiful interactive graphics using D3. If that's a little too much for you, you also can use a tool like Vega, which allows you to load up your data, explain what the visualization should look like, and take advantage of what it provides to create a web-based visualization.